Ladies, good morning. Good to see everybody here today, except for Emily. We know Emily's been watching. Good job, Emily. We're going to go ahead, limits to infinity analytically. And when we talk about limits to infinity, what kind of asymptote are we talking about? Are we talking about horizontal asymptote or vertical asymptote? We're talking about a horizontal asymptote. Thank you. Good job. Yes, very good. And that's really the definition of limits to infinity. If you go back to, I think it's Notecard 3, the beginning of it, that's what they give. We give as definitions, right? And here we get to something I've been talking about, which is Betsy Bobo Botu. And so we're going to be looking at possible uses of this. Now, so here, I forgot to say something. I'll show you. Okay, here, another thing, if you just have regular polynomial functions, all this applies. But another thing to keep aware of is that a logarithmic increase is smaller than a polynomial increase, which is smaller than an exponential. So you got to consider this kind of ranking as well, because in finding horizontal asymptotes, you may not always have pure polynomial functions. So we got to consider that. And sometimes you can see one of them be negative and so forth. So you have to do some thinking in addition to your Betsy Bobo Botu. So let's go here to some examples. And in the examples, we have this situation here. Did we already start working on these the other day? So we didn't quite start working on these. Okay, so in all three instances here, problems 1, 2, and 3, are we talking about polynomial functions? Yes, we are. Both in the numerators and in the denominators. Okay, so we're talking about polynomial functions. And so therefore we can look at our principle of Betsy Bobo Botu. And so if we look at number 1, is this a case of Betsy, or is it a case of Bobo, or is it a case of Botu? It is Betsy. How do we know it's Betsy?
They're both squared.
Yeah, both squared, right? The highest power is squared. Now sometimes they'll have little disguises, like one will be disguised. Do you remember one of the ones we looked at Friday? I'll show you. This one right here, problem 2 that we worked on, this one is actually Betsy. How do we know this is Betsy? Yeah, so the square root and the squared cancel out. So this is a Betsy but disguised. And I think we talked about this one here being Betsy, didn't we? And this one was Bobo. Yeah, so we did talk about that. So I wasn't hallucinating when I was thinking. Okay, so what is going to be the value for a horizontal asymptote for this one? Where's Betsy? So it's going to be y is equal to? Yes, 4 over 1. So 4 over 1, which what simplifies. So it's, again, bottom equals top, use coefficients. And if you turn back to that number 1 problem, example problem we were working at, I think it wasn't it negative 2/3? Something like that. Well, this one is 4. And now for problem 2, this one right here is, what is this one for a horizontal asymptote? So it's going to be y is equal to? 0. And the last one, 3, limit of x approaches infinity if 2x to the 5th minus 7 over negative Botu. So what's this going to be? Horizontal asymptote? Yeah, horizontal asymptote does not exist. We don't have a horizontal asymptote. Okay? So really that's it. So of all the things we work on this year, this, my friends, is really one of the easiest things we work on this year. Right? Yeah, pretty easy. But take some thinking, take some review on this, but it'll be okay. So, I think last year, you had horizontal asymptote problems, but we asked you to, like to use your calculator for it. You don't really need to. Now this one here, again, this is an AP problem with those asterisks over there. And so we have the graph has a horizontal asymptote, y equals 2, and vertical asymptote of x equals -2. Then a plus c equals question mark. And so what I want you to do is kind of puzzle with that for a little bit. This is one that over the years will occasionally give calculus students a problem. You're actually using the things that we've talked about, both in terms of vertical and horizontal asymptotes, very solvable, but it's sort of putting it all together in this problem. And so I want you to go ahead and see if you can figure this out, and then we'll go over it together here in a few minutes, all right? And you may talk to each other about this too. You haven't figured out, Elizabeth? Elizabeth, you haven't figured out? Okay, all right. Okay, Elizabeth says she hasn't figured out. Anybody else have it figured out? This one here is a little bit of a puzzler. I will allow.
Are we just doing packets all year?
For the most part, we're going to go ahead and, yeah, for the most part, we're pretty much plowing through this packet. That's most of the year. But we're going to do some backtracking back into pre-calculus too. Some of the, like, remember those sheets we had on pre-calculus? We're going to go back into some of those too later on this semester. I'm not exactly sure when, but there are parts of what we didn't go over last year that apply more this year. And I was sort of regretting it, but then the more I thought about it, I think this year is a good time to go over those that we missed last year. Carmen, you have an answer for this?
Not sure yet.
Oh, Karina, did you find out this one?
Yeah.
I absolutely have. Okay. What is going to be the easiest one to find first, do you think?
C.
Okay, I'm thinking A is the easiest thing to find first. Why do I say that? You know, horizontal asymptote is 2.
That divided by that equals 2.
Yeah, so we know that that 2x divided by x, well, ax, let's put it this way, I want to say it a little differently. We know that ax over x has to equal 2, right? And so what is A equal to? A is equal to 2, because that's the only way that works out. So A is equal to 2, so we know that. And then, do we really care what B is? No, so B really is sort of a red herring, sort of inconsequential. But we know we have a vertical asymptote where x equals -3, so how do we set that up? So we know that x plus c cannot equal what? Cannot equal -3, right? And then we have that, and so x plus c, we have vertical asymptote at x equals -3. Well, it's at x equals -3. Hang on a second. Let me write that differently. I made a mistake. So that can't equal 0. So -3 plus c cannot equal 0. So what's c going to be? So c is equal to 3. So what is a plus c? It is 5. Who got that?
I got the first part, but I...
Did you get this, the horizontal asymptote part?
Yes.
But just, yeah, to me, but you saw me working live on this, right? I had to sort of puzzle around and hunt around to get to it too, didn't I? But, so you got that, Karina? That's good. This is a puzzling problem. So this is an example of a problem that kind of looks like a hard problem, but then you kind of work through it and it's really not that hard, is it?
Yeah.
Yeah. But that's an example of you'll see that as a pretty typical for calculus problems. Bye. And so now, what we're going to be doing here, okay, just number 7, for x is greater than or equal to 0, again another AP problem. The horizontal line y equals 2 is an asymptote for the graph of the function f. Which of the statements below must be true? Goes back to the definition of what a horizontal asymptote is. And so if you have trouble with this, you can go to the note card and figure this out, I hope. So in this one, what must be true here? What is the definition of a horizontal asymptote? You think it's A? Okay. Well, let's look at some of these problems here. Okay, for A, f of 0 equals 2. So that means that if you plug in 2 to the function, if you plug in 0, you're going to get 2. So that means that we have a horizontal line y equals 2, right? Is an asymptote. And if we plug in f of 0 equals 2, but one thing you can look at as a counterexample, what if, for example, Elizabeth, you had this, like this function here, okay? Does f of 0 have to equal 2? No, it doesn't, because the horizontal asymptote doesn't have to do with what happens between negative infinity and infinity. What does it have to do with? Infinity. So it could be true, but does not necessarily have to be true.
Is it E?
Okay, let's check at E, right? In E, if we have that, there are different ways we can get it. One way is drawing it like we did there. Here's another way of drawing it. What if we draw it like this? Would that give us a horizontal asymptote of y equals 2? Yes. What about this? What if we went like this?
Yeah. It equals 2, 2.
It's small. It's going to be great. Now, this green one is a really good one because this sort of quells a misconception. Some people think that if you have a horizontal asymptote, it can't cross that asymptote. It can.
Because we have one like that on Friday that
Yeah.
did that over the 0.
Yeah, so Emma remembers the oscillating one, right? That
Yeah.
gradually diminished. Yeah, that's very good. So I want you, where you can in this class, what really helps is if you can sort of piece together memories of prior classes to kind of keep things together. So I'm going to give you some credit for that, Emma. That was really good. Good work.
Thank you.
I'll put a sticker on your homework assignment here. Okay, questions on that? Okay, let's go on to the sets here. Okay, so here, to me, what this looks like is more like one-sided limits. So it really looks like, is that what you have on your packet there somewhere? And so what it is, this is retracing back to one-sided limits. And Kinsey earlier was asking if we're going to go over packets this year, and pretty much that's right. But what happens within the packets are review materials. So in following the packet, I'm going to give supplemental stuff too, but basically in following the packet, you're reviewing as you go through the packets is what happens. So let's go over here, number 7. So we look at the limit as x approaches negative infinity of f of x is the limit as x approaches negative 1 from the left is, yeah, 1 from the left. It's going to be where? We approach 1 from the left.
Negative 2.
I get does not exist, or I'd say negative infinity. That's a type of does not exist, right? Because what do we have here as we're approaching 1 from the left? What do we get as we approach 1 from the right? Infinity. And so the limit as x approaches 1 does not exist. And what's going to happen on your first test you get in this class, I'm going to give you a lot of drawings like that for you to really evaluate what happens. So this is really, and I think it's the easiest part of the test, but what happens on easy part of the test sometimes?
You overthink and get wrong.
People overthink and still people will get it wrong. I hope no one gets these easy ones wrong, but it could happen. And f of 1 is, I don't see anything, right? And now the limit as x approaches negative infinity of f of x is?
Negative infinity?
Limit infinity. What is it going to be as x approaches negative infinity? Okay, we approach negative infinity.
Negative infinity.
That's not what it looks like to me.
Oh, 1.
Looks like 1 to me. Now limit as x approaches infinity of f of x is?
Negative 2.
Looks like negative 2. And
I don't know how you did that. Because that's what I thought the other one was supposed to be.
okay. So now we get to number 8.
Mr. D, how do you tell the first two from the last two? Because when you asked us the first question, I was going off the bottom part, because that's what I thought those topics were.
Oh really?
Yeah, so I don't know how you tell the difference.
Between what and what?
Like A and F, I mean A and E.
A and E. Okay, here, if you look at it, this one says, as x approaches 1 from the left. This one here is x approaches infinity. You see that now?
Yeah, but I don't know if that means it doesn't make sense.
Doesn't make sense? Okay. All right.
Because it was easier when it just had one line, I knew what one it was talking about, but I don't know.
Okay, remember, I think was it last week, or maybe it was the week before that somebody was asking about this, and so Hannah comes up here. I remember this very well. She received a lot of attention for it. So, I'll just look at number 8. So right now, on number 8, you see the limit as x approaches 3 from the left side. And so here's the 3. And so from the left side, it looks like this, doesn't it?
It says negative 3. I'm fine. 3 from the left side.
Yeah, it says 3 from the left side. And so we're approaching 3. And so we see, well, we're not coming to a number, so that's going to be, or does not exist. And my orientation got a little bit snapped. Okay, now as another example, what if this was instead limit as x approaches negative 3 of f of x? What is that going to be? Limit as x approaches negative 3. We got to go from the left like this, right? And then we go from the right to negative 3. And you see what this approaches here. So it looks like it might be like negative 1.5 or something like that. So you can just look at the drawing and go from the left and from the right. In this case, as we approach 3 from the right, we go toward what? Infinity also.
Because it doesn't
Which
touch
is-
the line, it just goes beside it.
Right, which is a version of does not exist,
Yeah.
really.
Even if it's not touching it.
Doesn't even get to it. Okay? Then the limit, of course, as x approaches 3,
Okay.
does not exist.
Or it's infinity.
Well, infinity is a version of does not exist. It's part of the does not exist family.
So it can be either.
Yes, it could be either. So it depends on how it's asked for. But so that's what it is. It's a way of not existing. Also, you see that negative infinity could be another way of not existing,
Yeah.
right? In this case, they're both going. One misconception that some people have quite occasionally, they think, okay, well, since the left-hand limit and the right-hand limit are the same, definitely the answer is infinity. Well, infinity is not a number, really. So the limit does not exist. So you can call it infinity if you want to, but that's a non-existent limit is what it amounts to. Okay? And now the limit as x approaches negative infinity, okay, instead of going toward a number like this, we're going like this. What number is being approached
1.
as we go this way? That looks like negative 1 to me,
I mean, negative 1 about that.
right? So negative 1. And then limit as x approaches infinity is,
Infinity. Or 0.
looks like it's probably 0. I can't tell exactly, but to me that looks like probably 0 is probably the best. And then f of 3 is,
Does not exist.
looks like it does not exist. So really, if you kind of keep things straight and are careful about making your drawings and all that. So are Emma, are you doing a little better on this? You're not? Okay, I gotta get Miss Nicole Moray's, or actually Miss King. So we might watch a video at the end of class. How's that? Yeah, that'll be good. I got a lady who does a good job of that, explaining what limits are. I think this would be a good class period for that. Okay, this one here on 9, the limit as x approaches 2 from the left side is?
Negative infinity or 35.
Yeah, negative infinity, which is a kind of a form, does not. The limit as 2 approaches from the right side?
Negative infinity.
Negative infinity. Okay, so Emma, are you seeing that?
I never know which way to make the arrow go to like north.
Well, here it says 2 from the left side, so that means we're going from the left side. It'd be like a north wind. If you say a north wind, the wind is in that direction, but it's coming from that direction, right? If we say the limit is 2 from the left side, you're coming from the left. So you're actually going right, because we're coming from the left. Just like the north wind comes from the north. Does that make sense? Okay. What about Kinsey? Do you follow Kinsey? How about you, Carmen? You follow what's going on pretty well? Yes? That was a small looking nod, but I guess I'll take her at her word. And then limit as x approaches 2 of f of x does not exist. And f of 2 is?
1.
Looks like 1. And limit as x approaches negative infinity of f of x is?
2.
Looks like 2. You see what that is? Does that make sense, Emma? Yes. Oh yeah. So here we have the limit as x approaches negative infinity. So that's this one right here. So you look like what number is being approached, and it looks like it's asymptotic to this horizontal line of y equals 2. And then the limit as x approaches infinity of f of x is?
2.
Looks like 2 because we're coming like this. It looks like we're being asymptotic to this y equals 2, so 2 goes here. Now for 10, the limit as x approaches 0 from the left side is? Looks like negative infinity. And the limit as x approaches 0 from the right side?
There's a hole.
There's a hole. So what's being approached here?
1? Negative 1, I mean?
Yeah, it looks like negative 1, right? Looks like we're approaching negative 1. So you don't see this very often. I mean, you can see it in a piecewise function, but that's what it is here. You just look at it. So what is the limit as x approaches 0 of f of x? Does not exist.
Is the next one going to be 1?
And limit as x approaches is that negative infinity? That's f approaches negative, yeah. As x approaches negative infinity, what are we approaching up here?
Mr. G, is D
Infinity.
Is D, oh D is,
1.
it looks like 1, thank you, yeah, thank you. That looks like that, yeah, you're right. I was skipping on to this one, sorry about that, yeah, good call. Okay, limit as x approaches negative infinity f of x is? Yeah, it looks like it probably,
4, 3.
it could be 3 maybe, but since it doesn't give us one of these horizontal lines, I would say based on what we have here, the thing does not exist, right? And limit as x approaches infinity of f of x is, well, this one definitely does not exist, right? There's no, this one up here, the one toward negative infinity, you could see that maybe if the thing continues like that, it could approach a number, but we don't have enough information to tell. So best we can tell, that's what it is.
So on the approaches like negative infinity and infinity, so like E and F, it's either going to be B and 8, or if the line's not there, Well, if the line's there, that's when the tutorial path.
Right, just like this one, for example, like number 9, right?
Okay, but if the lines aren't there, it's skating.
If the lines are not there, or there's not some kind of evidence that a line should be there, yeah, it does not exist. Yeah. Yeah, well, you look for evidence to see if things make sense. And now this one here, which is an oscillating version here. So right here for number 11, the limit as x approaches 0 from the left side is, looks like 0 to me, right? It looks like 0. Limit as x approaches 0 from the right side, 0. And the limit as x approaches 0 is 0. And f of 0 is 0. The limit as x approaches negative infinity of fx is, does not exist. Yeah, these are both does not exist. And that's one way you could have, and this is true for the sinusoidal functions that are like cosine x and sine x. You just have an unending oscillation, and that's a way for a limit not to exist, or a horizontal asymptote not to exist. Going to 53, okay, good. And 12, what is this one here? Limit as x approaches 0 from the left side, looks like 0. 0 from the right side, 0. F of limit as x approaches 0, 0. And f of 0 is 0. Limit as x approaches negative infinity. I'm thinking the best I could tell looks like, because we have that arrow, that to me that means probably continuing in that direction. I would say does not exist is your best answer. What about for f? Now, to me, I would call this 0. And why would I call this 0?
No clue.
Because look, you have this thing dampening. So if you follow a pattern, it could go like this, right?
Just keep going. I mean, it could.
It could, or maybe not, right? So it's really subject to assumptions you might make, right? I made the assumption that the thing is going to continue to oscillate in that pattern, but Kinsey is right on this also, because there's not enough concrete evidence, at least if she sees it that way, I'll agree with her, to verify that that arrow is going to continue down, right? So that's open to some level of subjectivity, that one. So I will take Kinsey's answer as valid for the very logic she gave.
So it could be 0 or D.
Could be 0 or does not exist. I'm thinking if the pattern follows of that, it's a 0. I want to, let me see, limits to infinity analytically. Okay, we're going to get some examples. What I want to do at the rest of class period, I'll play a video here that I hope will talk about one.